So thanks for coming to my talk. So today we're going to do a bit of a case study looking at a game I built in Elixir for a bit of fun and to learn some stuff. So it's Tetris, spoiler. Oop. Okay, so we're going to go through, so who is this guy up here talking to you? And what is the thing we're actually going to look at? So what's the game? And then we'll look at how things are displayed on the screen. Ooh, it's stuttering a little bit, but fine, I'll just continue. And then we're going to look at how the audio works. Then will be the moment of truth, where we try to play it together. It's a game, it's online. We can all join a big game of Tetris. Hopefully it will work. And then we'll look a bit at how it actually is built, what the process architecture is, if this is something you could use in your own applications, as well as control flow and a bit on optimization if we have time. Apologies for the stuttering. So who am I? So I'm Merlin, hello. Tech lead at Multiverse, so we're trying to make it so you don't have to have the fancy university degree to get the fancy jobs, apprenticeships and that kind of thing, ed tech company. So I've been doing Elixir for maybe like 2 years, so fairly new to it. And that was part of this project, was kind of to get better at Elixir and Phoenix and CSS as well. It says here, I'm barely a front-end developer. I started as a hardware engineer and then slowly worked my way into functional programming and web dev. So that will be oh, has it gone? The barely a front-end developer thing will be reflected in the UIs you see, so apologies for that. I'll see if I can sort something out about the display. It's a bit jarring. I'll just continue. So I'm not on Instagram or Twitter or anything, but you can find me on GitHub and LinkedIn if you're interested. So what was the goal when I started out? I was at Lambda Days, seeing all these cool projects people had been doing. And I was thinking, it'd be kind of fun to build something myself around this. So I got thinking, can I build Tetris in Elixir? So embarked on a little mission to do that. And I kind of thought it'd be cool to have a lobby as well, where we can have multiplayer games, and you can see who's there. Just an excuse to play with Phoenix presence and PubSub and things. Then it was, can we make it so you can have multiple players in a game at once? I think so. And then can we get 100 players in a game at once? Not so sure. We'll see. I've not tested this with all these people, so it might work. I don't think it will crash. It might be really slow with the conference center Wi-Fi, but we'll see. So this is what it looks like. You've seen Tetris before, I'm sure. So your game is in the middle, and your opponent's games are to the left and right. If anyone's played Tetris Battles before, or sorry, Tetris 99, I think it's called, Nintendo Switch game, it looks quite a lot like this, although they actually have proper front-end developers, so it looks quite a lot nicer. And yeah, that's pretty much it. I'll point one important thing. There is a volume toggle here. When we get to playing, you might want to press the volume toggle, because there's going to be 100 games of Tetris playing at the same time. It will get a bit noisy. Cool, so why did I actually build it? I think I've alluded to this a bit, but it was really to improve my own skills and get more used to the tech stacks and that kind of thing. And as I started doing it, I thought this might be an interesting example project for other people that want to learn how to do this kind of thing. And the main reason is just because writing code is fun, right? We spend a lot of time doing proper production systems, and we don't spend that much time doing all the cool, fun games and that kind of thing. So a good excuse to write some fun code. So it's a Phoenix project, Elixir, Phoenix LiveView, Tailwind CSS. Tailwind CSS I found super useful for making it so that I don't have to understand CSS properly. It will teach me. And it's all deployed on Fly.io, which was an amazingly painless process. I was very surprised. I ran one command, and it was suddenly on the internet. There's no database. I tried to avoid having a database if we didn't need it, just because it adds complexity. Cool, so here's what the mobile version of the game looks like. It's just CSS breakpoints to make it look like this when it's on a small screen. It's all just HTML and CSS. There's nothing clever going on with the graphics. It's not WebGL or anything like that. It's pretty basic. And the board you see there, that's just one big SVG. We're just iterating from the top left corner to the bottom right-hand corner through the model to see, hey, should I color this square in at all? Should I color it in purple? Should I color it in blue? And then it's just doing that for every update. And if we're lucky, we can make use of Phoenix LiveView and DOM patching with minimal diffs to mean that this isn't a terrible rendering experience and that we only update the bits that we need. So in theory, it should work. LiveView is doing all the heavy lifting here, so it's also sending the audio signals like start the music, end the music, capturing key presses, etc., etc. So is it any good as a project? It's maybe an example you could use if you want to build something yourself, and it's a bit of fun. It's probably not production ready. It is out there in the world, but there's lots of to-dos in the code. The test coverage is questionable, but it kind of works, I think. We'll see. And you probably don't want to try rendering complex graphics in HTML and CSS. I mean, up to you. You might be able to make it work. OK, that's enough waffling. Let's give it a go. So what I'm going to do is I'll load up the game here, and I'll ask anyone else who wants to get involved on your phones or laptops. You can go to tetrex.fly.dev, and it should load up. I'll do a single-player game first, just so you can see what it looks like and what to expect. And then we'll drop into a multiplayer game and see if the server explodes or if it all works very nicely. I've not got around to putting the controls in the game yet, unless you're on mobile, so they're there. It's the arrow keys and H to hold tiles, and then space to drop. You can't pause the game with escape in a multiplayer game. But OK, excellent. I can see we've got 37 of us here already. Oh, great, yes, people are joining. For anyone watching online as well, please also join. You're very welcome to get involved. It should work just the same. Oh, I can see some people have already started their multiplayer games. Oh, you can play on your own. Cool, so I'll start a single-player game first. So let's see if we get audio. We don't. Oh, well, doesn't matter. It would be a bit annoying anyway. And it's Tetris, right? So I can move around. I can drop my tiles. Oh, I can already see it's lagging. This is going to be fun. I can rotate my tiles, blah, blah, blah. I mean, you've probably played Tetris before, so mute button up here, just reminding you. Cool, so I'll just join whatever game has the most players, since we've already got 13, 14 in this one. OK, we're going to go for this one. It's got a very nice to see user ID, or game ID, sorry. Oh, there we go. So it starts with 9F is the one people seem to be joining. I'm the one with the most players. So if you want to get involved, go jump in that game. OK, so normally, we would sit here and wait for everyone to press the I'm ready to play button. But I'm not going to wait for everyone to press the button, because it will never happen. So I've added a secret admin panel where I can just force the game to start. So I'll wait a few seconds. I think we've got 51 people in now. And I'll do a 3, 2, 1, and then I'll just make the game start, and we can see what happens. We won't play for a whole game, because it will take kind of a while. But I've got a button here I can press to make the game speed up and slowly kill you all. So that should get through it pretty quickly. Cool. Oh, I've been abandoned. Someone's started the game already, or maybe it's already started. Oh, OK, cool. People actually pressed the ready button. I'm very surprised. Wow, there's no audio going on in the room. Does one person want to unmute so we get the lovely Tetris theme? Yeah, this is kind of expected. I think doing server-side rendering on conference Wi-Fi with 50, 100 people is maybe not going to work so well.
You didn't test this beforehand?
Pardon?
You didn't test this beforehand?
Oh, I tested it beforehand and it didn't work very well. But I thought, what's a better place to test it properly than with all of you guys? OK, this is a horrible laggy mess. I'm just going to leave you guys to keep playing in the background if you want, if you can, and I'll continue with the talk. Cool, so we're going to have a quick look at how it's built. So how did I design the thing? We'll do a really, really quick OTP recap just on gem servers and stuff for anybody that's a bit newer to this. And then I'll look at the types of process we've got going on to connect it all together, and a bit of how data flows and what happens when you press a key. Cool. Gen servers. Async OTP processes, read from mailbox. They have private state, and they can send messages to other places. You've probably seen them before. Supervisors. Async OTP processes. They can make child processes, and they can manage their life cycle. So if they die, they can restart them. Dynamic supervisors, just the same, but you make them on demand. This is quite important for us, because if you've got a game going on, and you want a player to join, and you want them to have their own board, you can't just rely on all of the boards being defined at the beginning of time. You need to add one on the fly. So that's what we're using them for here. And we're using PubSub for almost all of the communication here. So processes published as a message. Any processes that care about this can subscribe to it. This is provided by Phoenix, and it's just some nice magic that works on top of OTP. We're also using Phoenix Presence in the lobby, if you saw. We had a live updating player count. It's just built on top of PubSub to tell you, hey, we've got 50 players have joined, and you get live updates for when people come and leave, join and leave a page. Cool, so this is a bit wordy. I've got a diagram for it in a second, but just to briefly explain kind of what's going on. So for single player, it's just the same as multiplayer, but less stuff. So we've got a dynamic supervisor that's spawning games on demand, as I kind of mentioned a minute ago. And then we've got a game server. It owns the state of the game. So this is when you know if the game is playing, if it's all the players have died, what the score is, et cetera, et cetera. Oh, sorry, if the player has died, it's a single player game. And then the next level down is we have the board server. So it has its own state, and this is kind of the low-level state of where are all the tiles, what does the whole tile look like, that kind of thing. And then the missing piece to all of this is, OK, so we can press the down key, and the tile will move. But the game should just keep doing things on its own. It's a bit easy if you just control it fully. You want the stress where the tiles move down. So we've got this periodic thing, which is just sending a message every X period to push the thing down. Multiplayer, much the same, apart from now we have a game server that spawns new boards on demand every time a player joins the game. And if they leave the game, it kills the OTP process and cleans that up. Process manager, I won't go into really. It just traps exits and makes you leave the game if you close the browser tab. The code's all available online if you're interested. These are super simple little gen servers. So you're never going to be able to read this diagram, but I did think of this one in advance, and I've got a slightly easier to read diagram, which you might not be able to read anyway, so we'll give it a go. So here we are, the player, on our single player game, and we're going to press the up button. What we expect to happen is the thing's going to rotate, but what does that actually mean in terms of what does the program interpret this as? So the browser client is going to detect the up button has been pressed, and it's going to send over Phoenix using all of the JS hooks. Oh, please come back. OK. It's going to send a message saying, hey, the button was pressed. Hopefully it'll come back. OK. And the live view is going to translate this to meaning I've rotated. I'm just going to ignore it and pretend you can still see it. This is available online as well if you want to have a look. Yep, go ahead. Okay, I will try and quickly fix that. Do you know where I might find that? Okay, on with the terrible user experience. Okay, well, it's stable for the moment. Oh, never mind. I'll just try not to touch it at all. Okay, so we sent the button press to the live view, and it knows, okay, up means rotate the thing. So then it's going to send a message down to the game server, which holds the game state, and it will say, oh, I've been asked to move the tile up, but I don't actually control the board. This lives somewhere else. So I'm going to talk to another process, which holds the board state, and this is the board server. You can see kind of how it holds the board state here. It's super simple. It's just a map of coordinates to what is the thing there. So it might be a blue tile, it might be a red tile. So it's going to ask the board server to rotate the tile. Some maths will happen in the background. It's very simple maths. It's just a little bit of really basic matrix maths. And then it's going to pop back up. And Great, so now the game server knows that the tile is rotated, and it should probably update the display somehow. But how does it do that? PubSub. PubSub's pretty magic. In this case, it's kind of a little bit overkill, but you'll see why we've used PubSub in a minute when we look at the multiplayer stuff. So it's going to broadcast a message, and then the LiveView knows about this, and it can go and update the display again. And hey, the tile is rotated. As this is an example project for people to kind of explore and see how this stuff works, all of these blobs have little GitHub links that will take you to the correct piece of code. So if you're interested, check it out. Any questions on any of that? Nope? OK, perfect. I'm just going to assume that everyone understands perfectly. So I won't go into too much detail on this, because we've kind of covered it all with the single-player game. But now the PubSub stuff makes a bit more sense. So a player presses the left button, same thing happens, goes down, changes the state. But now we need to update multiple browsers to say, hey, you should probably show that this person's tile has changed, because we're showing the board on multiple different browsers. So these could be anywhere, right? So it's not quite so simple. But PubSub, again, PubSub is magic. We push the messages into PubSub, and then suddenly all the live views know that we've updated the state, and they'll push these DOM changes out to the browser clients. One extra thing here is I've added a little timer to push the state out periodically rather than on every state change. Because, well, I'll see if anyone can guess. What happens if you have, let's say, 100 players all playing at the same time, all pressing the down key at the same time, and you're trying to update the state every single time? Any guesses? Yes. Yes, you try to update the browser 10,000 times a second. That doesn't really work very well. So we've got a more traditional publish regularly type thing.
You don't have some update regularly on the other side?
For the single player, I didn't bother, because there's just so few updates. I may as well just push it as soon as it happens. Like, you could just as easily here have returned the game state directly as a synchronous thing for the single player. Like I said, it's massive overkill for single player. Cool. Any questions on that? Yeah, go ahead.
So does that mean tile rotation can only happen once a refresh? Once a cycle? Once a second?
Yes, once per cycle, but it depends what we set it as. So I've tuned it, well, there's a config variable, but it's at 30 times a second at the moment. So it just has to be faster than the user can notice, and it should be OK.
Yeah, I have a question about the differential DOM updates. And you mentioned that basically the entire board is one SVG. So I don't know, how does LiveView handle that? Does it do it differently SVG, or do you always get the whole thing?
I can tell you what I think happens. I think, because it's all just XML, LiveView is clever, and it will see this part of the XML has changed. Because I'm rendering an SVG, and then inside that SVG tag, I'm rendering lots of rectangles. So it should just see, oh, this rectangle has changed. I'll send the update for that. I think. It seems to work. So,
Yeah. Okay, thanks.
Cool. OK, I've just called this time for an overwhelming diagram. I'm not going to go through the diagram in detail now, but it's just so that you know that it's here in case you are looking to use this as an example project. I've linked this mirror diagram. There's an overwhelming diagram on it. There's a lot going on. This is a full map of how the whole application works, how all the supervision tree works, all the data that's being passed between things, what the data structures are. And every one of these blobs has a link to the GitHub, well, to the code on GitHub, so you can check it out. If you want to see what the supervision tree is doing, start on the left and work your way across. So over here we've got the application spawning a bunch of stuff, supervising a bunch of stuff. Or you can start up at the single player over here and follow through what happens when you press a key, or same for multiplayer. There's some stuff for the lobby as well. Again, not going to go over it now, because I don't know how well it will display on here, but it's there if you want to check it out. I'll link it on the GitHub repository as well. How am I doing for time? Yeah, I think I'm OK. So you can imagine me coding away, and yes, perfect. I've got multiplayer working with 2 players. So this is ready, right? I can roll it out to everybody. So how does it work with 50 players? Not so good. A horrible laggy mess. Still a horrible laggy mess when we played it. I'm gonna blame the conference center Wi-Fi and not my terrible code. But some improvements were made anyway. It would be completely unplayable without them. So some types of lag that I thought about and possible solutions. Firstly, the server might be doing way too much stuff, and I'm just asking too much of it on this tiny machine, and I should probably reduce what's going on there. Thought of a solution for that. I'll tell you if it worked or not. Well, you can guess if it worked or not in a minute. The other solution would just be to use a bigger machine. I put a sad face. That's a bit of pretty rubbish cop-out solution. Then looking at some sources of client-side lag. So maybe the browser is trying to do too much, and I'm just asking too much of it, and I should do things more efficiently. So some possible causes here. Maybe I need to change how much is changing between frames. As an example of this, if I don't sort the boards that are displaying on the sides, and between every single frame they jump around, that's a lot to re-render. It's also a terrible user experience. So that's something you could try and improve. And maybe there's some things we could do around like updating the DOM less frequently, or yeah, I'll show you on the next slide some things that we did. The last thing I considered was network lag. I figured there's not that much I can do about this apart from send less data. I think you all experienced network lag, but what can you do? So the question I asked myself is, am I just sending too much data to the live views? So this is inside inside the beam. Am I just broadcasting way too much data on every state change? So putting an enormous message in the mailbox of every single process, every single live view process. So I thought, cool, well, this sounds like a good excuse to do another project, right? So maybe I should make something that will diff two maps or diff two deep data structures in Elixir, and then you can use that diff to patch your state. So you just send a tiny little diff on every update rather than the whole state. The code is here. If you're interested, it's available. This is kind of what it looks like. You make a patch from two things, and then you can apply the patch. You've used Git before. It's just like Git, but in Elixir. So was this a good idea? Did it improve performance? Any guesses? Hands up for yes, it improved performance. Okay, we've got one lonely person. Hands up for no, it didn't improve performance. Yes, good, you're all correct. It made performance way worse, don't do this. But it was a fun project anyway. So next I looked at client-side lag. Like, this is probably the problem, right? So is my rendering just too inefficient? So what was I doing? So I told you that the board is now one big SVG. Previously, it was 200 little SVGs, one for each tile, and arranged using FlexGrid, because CSS can do this for me, right? Why would I write it myself? Obviously, that's really naive, and it was a bit of a problem. So the solution was just to actually bother writing the proper code and iterate over the thing and draw the SVG myself, rather than asking the browser to nicely arrange it for me in CSS. Do you think this helped? So hands up for yes. OK, a lot more hands. Hands up for no. It was a yes. Yeah, this one helped quite a lot. This made it go from, you can have maybe 5 to 10 players in a game to like 20 players in a game, and the browser doesn't immediately crash, which was what was happening before. So the next thing I thought is, am I just sending too many updates from the server? Am I asking the browser to refresh too many times per second? So what was I doing before? Well, same as we were doing in single player. Anytime any of the games update, we try and refresh the browser screen. This is a lot of state to change and a lot of messages to be processed and a lot of stuff to be sent to the browser. So maybe I should not do that. Maybe we should publish at a regular cadence of, let's say, 30 FPS for an initial guess. Any guesses? So did this help? Hands up for yes? OK, that's a lot of yes. Hands up for no? OK, no one thinks this didn't help. Yeah, it helped a lot. This one, I'm really glad I got in, because this was actually just on the train over to Germany. I managed to sneak this one in, so thinking, damn, it's going to be a real disaster, but I'm glad I got that one in. Cool. Well, that's everything. So thank you very much for coming to the talk. Any questions on any of that?
I'm curious how you picked 30 frames per second, because that's actually pretty high for something that's so low res.
That's what all the cool games do, right? It's a config value. I tried 30 on the train, like, yep, seems to work. That'll do.
With just you. Okay.
Any question?
So I was wondering, so you are publishing every 30 seconds from each of the clients, and then the subscribers of the topic are reading those publishings. So I'm getting one publish from every other player. So I'm getting, if I'm playing with 100 players, I'm getting 100 messages.
Fortunately, not quite as bad. So we have the game as a single OTP process. That all of the boards for the players are separate OTP processes with their own state, but we have one game process that handles all of the requests to move left or right or anything. So we've got one place that needs to do the publishes 30 times per second, and then all of the live views that talk to the browser clients are what receives that. So you have, you push updates to maybe 50 things rather than like an n squared, like 2,500 things type situation.
Yeah, so you are only receiving the update from the game, and it contains all the updates from every player that we're playing with.
Yes, yeah,
Okay,
you kind of batch them together, just anything that changed.
So you are batching both before and after the pub-sub chain.
What was that, sorry?
So you are batching before and after the pub-sub chain.
Yes, so anything that's happened up to that point since the last refresh, just publish the new state. That's quite a lot of data, right? So that was the idea of maybe we should send diffs, but that's a terrible idea, so don't do that.
Any more questions? Let's see if we have any in the Wova app. If you are on stream, you can write your question in the Wova app, and then we can ask here. We have a question from Maru. Are you here to ask your question? I can read it out. So they ask how to create interactive experiences in Elixir.
How to?
Create interactive experiences.
Well, very general question.
Very.
You can make heavy use of OTP, right? Like you can have a lot of players connected to one machine at the same time. And if you're clever with not sending a million updates, then you can make it pretty interactive. PubSub and things like that help a lot. Yeah, it's a template you can use.
So, any more questions? No? Thank you for the talk. That was really interesting.
Thank you very much.